going to continue to work with exponents, and in this lesson we're going to learn how to work with negative and zero exponents. Let's start with zero exponents. Anything with the power of zero. So let's take a variable that represents any number. Anything with the power of zero is 1. Pick a number, 1 or 100. Anything with the power of 0 is 1. Okay, why is it? I'm going to prove it to you. Let's take 2. Let's say we have 2 cubed, 2 squared, 2 to the first, 2 to the power of 0. We're going to find a pattern with its exponents to prove to you that anything with the power of 0 is always 1. So, 2 cubed, 2 times 2 is 4, times 2 is 8, 2 squared is 4, 2 to the first is 2. You're going to notice that our answers are forming a pattern each time they divide by 2. So 8 divided by 2, 4 divided by 2, 2 divided by 2 is 1. And this works with any base number. You can prove it with any base number. So anything with the power of 0 is always 1. Negative exponents. When you have a negative or any number base, and it has a negative exponent, so n represents any number, what happens is it turns into a fraction where the base and the exponent go to the denominator. Notice when it moves to the denominator, this negative goes away. So this negative in the beginning of the problem tells you that you need to change the problem into a fraction, and this gets moved into the denominator, becomes positive. Let's look at an example. Let's say we have 2 to the negative third. That negative in the exponent tells us that the base and the exponent moves to the denominator, and then the exponent becomes positive. Let's try some of these. We're going to mix the 2 together. We're going to try 50 with the power of 0, 7 to the negative second, 1,000,000 with the power of 0, and 3y to the negative second. Push pause and try those now. So we learned 0 exponents mean anything with the power of 0 is 1. Negative exponents tell us to move the base and the exponent to the denominator. The exponent becomes positive. Anything with the power of 0 is 1. Okay, this one's different than this one because here my base is y and my coefficient is 3. This negative exponent only belongs to the y. So the only thing that's moving to the denominator is the base and the exponent, which is 2. The coefficient does not have a negative exponent, so it stays in the numerator. Try a to the negative fifth, b with a power of 0, 4m to the negative fifth, and cubed. Just pause and try those now. So I'm going to break this into 2 parts. I'm going to work with the a, and then I'm going to work with the b. So the a has a negative exponent that gets moved to the denominator. B, the power of 0, that's positive, a positive exponent. Well, technically 0 is neither positive nor negative. But because it's not negative, you don't move it to the denominator, it stays in the numerator. And anything with a power of 0 is 1. Nothing happens with this 4, it has no negative exponents. N to the negative fifth gets moved to the denominator. Oops, when I move it, that becomes positive. N cubed, again, there's nothing negative with it, so it stays in the numerator. There is no more we're simplifying with this because these two variables do not have the same base, so we can't divide or subtract the exponents as we learned in the last lesson. Here are your instructions for the next section. It says, rewrite the expression without using a fraction bar. I'm just going to say write. Rewrite is a weird. Let's say write the expression without a fraction bar. So let's start with the easy one. 1 over x. Our goal is to get rid of that fraction bar. Essentially, we're going to be doing the opposite of what we were doing in the last slide. In the last slide, when we had a negative exponent, we moved things to the denominator. If we, in this slide, if we have stuff in the denominator, we're going to get rid of that denominator by moving it back to the numerator and making it have a negative exponent. So this, when I move this into the numerator, becomes a -1. Technically, the numerator, there's a 1 out here, but the most simplified answer is x to the negative first. And you are going to get problems like this, where we're going to want to move that 25 to the numerator again. So 25 is the negative first, but you're going to have to write it using prime factorization. So let me just give you, you can probably figure out what 25 is using exponents in your head, but this is what you would do if you're not sure what the prime numbers of 25 are. You would set up your factor tree or your ladder diagram, find the prime numbers, and then list them using exponents. So 25 is the same as 5 squared. So I'm going to think of this as 1 over 5 squared. And to get rid of the denominator, to move this stuff into the numerator, my final answer is 5 to the -2nd. And I no longer have a denominator. So I would like you to try, I have 3 of them here for you. 1 over 16, x to the 6th over y cubed, and 2a to the 8th. Push pause and try those now. Okay, so I'm going to start with 16, and my goal again is to rewrite 16 using prime numbers. So if I don't know how to break 16 down, I'm going to use a factor tree or a ladder diagram. Here, I see that this is 2 to the 4th. So this fraction really says 1 over 2 to the 4th. And to rewrite it, I would move this to the numerator and make my exponent negative. This second fraction. This x to the 6th is going to stay in the numerator. I don't need the fraction bar to write that. I have to move 3 cubed. So I'm just going to move that to the numerator. And when I move it to the numerator, you get a negative exponent. This one's similar. This 2 is going to stay in the numerator. I don't need a fraction bar to express that. This a to the 8, to move it to the numerator, you need to make it negative. One more section. Let's see here, our instructions. Write your answer using only positive exponents. So this again is kind of the opposite of the last slide. The last slide, our goal was to write a negative exponent to get rid of the fraction. fraction bar. Here, they're going to give us negative exponents, and we're going to use fraction bars instead. So again, we're flipping back to the opposite. Let's try 3 to the 8th times 3 to the negative 10. And there's two ways I can think of solving this. We are going to have to use the rules from the last lesson. I see that this is a multiplication problem. They have the same base. When we're multiplying powers, we add their exponents. So here, my base stays the same. 3 plus a negative 10 is a negative 2. But our answer cannot have negative exponents, so I'm going to have to take it a step further with the rule that we learned today. When I have a negative exponent, it tells me to move the base and the exponent to the denominator, and the exponent becomes positive. Another way to do this, you can rewrite this and move this to the denominator. Okay, this becomes a division problem, and you're going to subtract the exponents. 8 minus 10 is 3 to the negative second. Because I have a negative exponent, I need to move that to the denominator. Try n to the negative third times n to the negative first. Okay, again, I see that we're multiplying, so I'm going to add their exponents, same sign sum. And then, because I have a negative exponent, I'm going to move it to the denominator. I prefer to multiply first instead of stacking them on top of each other, but you may also use this method. 10a to the 4th over a to the negative 4th. You have to be very careful with the exponents. So here I see that these a's have the same base. I'm going to subtract their exponent. Think about what this says. This says 4 minus a negative 4. So if you would have done 4 minus 4 to get 0, you would have gotten the wrong answer. 4 minus a negative 4 because we're dividing, plus the opposite. This actually says 10a to the 8th. And then there's no more simplifying to do. Now this 10 I just brought down, there's nothing that you could do with that, so I just brought it down in my answer. Try 0.8 n to the negative third all over n squared. Again, be very careful with your exponents. This is a division problem, so we're subtracting these two exponents. Negative 3 minus 2. Keep switch opposite. This is actually same sign sum. The 0.8 doesn't change. There's nothing you can do with it. And this becomes n to the negative 5th. I'm going to rewrite this so it looks better. This one you have to take a step further because we can't have negative exponents. This negative only belongs to the n. So it's the n to the 5th that moves to the denominator. The 8 does not have a negative exponent. I would like you to try 2 more. Try 26 w to the negative 4th over 13 w to the negative 12th. And also try x squared y over x to the 10th y to the 7th. Now this squared is in a weird spot. It belongs to the x, not the y. Go ahead and try that now. Just like before, when you're working with coefficients and variables, you're going to split this into 2 parts. I see I have a fraction, 26 over 13. I need to pull out the greatest common factor, and I see that I can divide both the numerator and denominator by 13. So this becomes 2. 13 divided by 13 is 1. Now I'm going to work with the variables. It's division, so I subtract the variables. Negative 4 minus a negative 12. Keep switch opposite. This adding integers is different signs, so it's actually subtraction. 12 minus 4 is 8. Now think about the best way to write this. Do we need this over 1? No, this over 1 doesn't change anything. So our answer is 2w to the 8th power. I see I have 2 variables in this problem, so again I'm going to work in 2 steps. I'm going to start with the x's. It's a subtraction problem, 2 minus 10. And maybe I want to do keep switch opposite of this one too. We get x to the negative 8th. And now the y's. When a variable doesn't have an exponent, there's a 1. So that says 1 minus 7. Keep switch opposite. I get y to the negative 6. Our answer cannot have negatives, so I'm going to move both the x and the y to the denominator because they both have negative exponents.